Hello, everyone. We're just getting started and I'm going to wait a few minutes for people to file in. And I'll also start a screen share. Okay, I think we'll get started right away today. Great to be here. My name is Lowell Wise. I'm Executive Director of Tacoma Tree Foundation. I know many of you on the webinar today, so it's great to see your names. And we're really happy to be here with Dr. Ailene Ettinger from the Nature Conservancy to talk about trees and temperature in Tacoma. So a quick note at the beginning here, we're broadcasting from downtown Tacoma. This is the land of the Puyallup people, where they make their home and speak the Lushootseed language. This land was not ceded over by choice, and we think it's important, since we do work that affects the landscape and hopefully cares for the community, that we acknowledge the ongoing stewardship of the Puyallup people and other Coast Salish people as well. Quick logistics note about webinars. You can ask questions anytime by using the Q&A function on the webinar. There will not be an open chat. We're getting good at this, but sometimes there are still glitches, so be patient with us, please. And then finally, we're going to open this up to at the end for questions. And we're going to do something different this time, where we allow people to unmute themselves and ask questions and have a little bit of a conversation, hopefully. So we'll be sorting that out. The webinar is also being recorded, and it will be available later on our YouTube channel. So you can take a look at Tacoma Tree Foundation on YouTube to find all of our list of previous content. Couple announcements here at the beginning, since I've got an audience here. Happy Earth Week to everyone. Saturday is Earth Day. There's so much going on. We actually run a calendar called earthdaysouthsound.org. And if you go to that link, you can find information about anything and everything that's happening all during Earth Month in April. And especially on Saturday, there's like a dozen or more events going on. We're going to be at the South Sound Sustainability Expo in Tolleson Plaza, downtown Tacoma, with our partners at City of Tacoma Urban Forestry. There's going to be a pop-up forest installation that's going to be really cool. And we will be giving away some trees and shrubs to anyone who stops by and has space to plant. So that's on Saturday at 10 o'clock. There's also a nature symposium from one of our dear friends and partners, Sarah Lowe, happening at Point Defiance on Friday and Saturday. So I encourage folks to go to Earth Day South Sound and check out the events happening on Friday and Saturday. There's also an event at the canoe landing site with the Puyallup tribe happening this Saturday. These are just a few things that are going on and where you can find us this weekend. In terms of the Nature and Healing Symposium, just wanted to mention that we are also sponsoring a tree walk at the end of that on Saturday afternoon. So all the details are on earthdaysouthsound.org. One last thing is that we've got our lineup finalized for our annual State of the Urban Forest event. And this event is going to be happening on May 25th. It's going to be in person with no hybrid option. So we'd love to see you in person. Come down and join me and my colleagues at City of Tacoma to hear about the urban forest and hear about the connections with climate, what the city's been doing lately on tree policy, and what Tacoma Tree Foundation is doing as well. So we'd love to see as many of you as we can. There's a suggested donation of $15. And yeah, hope to see you at State of the Urban Forest. So with that, I'm going to introduce Ailene. It's great to have Ailene with us again. Ailene is a quantitative ecologist for the Nature Conservancy in Washington, who has studied diverse species and systems, from old-growth forests in the Pacific Northwest and tropical bee communities and coffee farms to suburban vernal pool amphibians and southern resident killer whales. So at TNC, Ailene works to protect and restore lands in Washington. has a PhD in biology from University of Washington, and does a lot of great work here and around the world. So really excited to have Ailene with us and to be a partner with Ailene and the Nature Conservancy on this project that you'll hear about today. So with that, I'm going to turn it over to you, Ailene.
Great. Okay. Here we go. I'm going to slideshow here. All right. Let me know if you can't see my PowerPoint slide. And also do let me know if you're having any problems hearing me, or if hopefully my internet will hold for this lunch and learn. I'm really happy to be here, and thank you, Lowell, for taking time out of your busy schedule to allow me to talk to your audience about trees and temperature in Tacoma, and also to talk about, well, I'll be talking about a research project and collaboration that I'm really excited about called Greening Research in Tacoma. And this collaboration is made up of these key partners. So of course, the Tacoma Tree Foundation, several of us at the Nature Conservancy are involved in this work, as well as some researchers at the University of Washington, and urban foresters at the City of Tacoma. And this project, well, we'll get into the details of it later, but I'm going to be focusing on one component of this project, which is the environmental research component. And I did just want to mention, before I get into the topic at hand, a little about the Nature Conservancy, in case it's an organization that you're unfamiliar with. So our mission is to conserve the lands and waters upon which all life depends. And we are working to tackle climate change with partners of ours, like the Tacoma Tree Foundation. We do this work here in Washington. So there's a map there of some of our preserves and easements across the state. And we do also do this work around the world. So there's I think close to 80 countries in which we touch down. I'm happy to answer questions about the organization, as well as the work that I'm talking to you about today at the end. So, as I'm sure many of you are aware, temperatures are rising around the world, and I think many of us have experienced this here in the Seattle-Tacoma area, especially in the summer. So the past several years, here's kind of a snapshot of how we might have experienced that warming here. In 2021, June was the hottest June on record for the contiguous United States. And so here's just a map showing some of the difference between average temperature and the average June temperature that year. So you can see dark red means warmer temperatures compared to the average. Blue means cooler. And then this is part of a kind of trend of warming that you can see in that bar plot down at the bottom, where you can see in recent decades, many more occurrences of hotter than average temperatures in June occurring. And here in Seattle, that particular June had several really hot days. So you can see the kind of gray is like typical conditions across the year. And the temperatures in June 2021 were extreme, as you may remember. 2022 was not quite that hot, but there were some really hot days then, as well as during the summer of 2022, as you may recall. And as I mentioned, for the country, this is part of a larger trend here in the Tacoma area. A similar trend has been observed. So just the number of days above 82 degrees Fahrenheit as a sort of target temperature that can trigger some extreme heat conditions for people is shown on this graph here. So temperatures have been, the number of days above 82 degrees have been increasing over the most recent decades. This is from an urban heat island analysis that was done in Tacoma, Washington a couple of years ago. It's really interesting and widely available. So I recommend Googling it and checking it out. I guess the good news is that we do have, in the form of trees, a kind of readily available way to help buffer some of these impacts from climate change, some of these heat impacts that we're experiencing, especially in cities like Tacoma. So as you may have heard the term heat islands and urban heat islands in particular. And this phrase refers to the hard surfaces that occur commonly in cities, like pavement, and that these can trap and store heat much more than sort of natural vegetated landscapes. And this results in elevated air temperatures in cities that can be up to 22 degrees warmer than surrounding areas that are more vegetated. But urban trees can help us reduce this heat island effect. And urban trees can help buffer other impacts of climate change too. But today I'm going to focus on kind of the temperature effects, and our Greening Research in Tacoma project so far has focused on the temperature benefits of trees, at least in the environmental effects that we're measuring. But yes, there are many, in addition to temperature, there are many other benefits of trees and ways that trees can enhance climate change resilience and climate change adaptation in cities. I'm just showing a few of these examples here. In addition to that, trees, the health benefits of trees have also been widely studied and quantified in some cases, ranging from benefiting our physical activity to helping reduce stress and it can help support social cohesion. So I certainly don't want to forget, or I want to remind you of all these other benefits, even though today I'm really going to be focusing on the temperature side of the benefits of urban trees. So despite all these many benefits, it seems, so I guess because of these many benefits, you might think we should all go out and plant a lot of trees, which would help solve this problem, but it's unfortunately not a simple or straightforward solution. There are planting space issues that cities and foundations like Tacoma Tree Foundation have to encounter. So where can we plant trees? There's also maintenance costs to keep those trees alive once they're planted. And another challenge and complexity related to this issue is that trees are not distributed equitably across cities. So this figure that I'm showing now is from an analysis that was done across the US, combining tree cover data, which is what's shown here on the y-axis, so percent cover, with income on the x-axis. And you can see this pretty strong relationship of higher incomes are associated with higher tree cover. And this is the pattern that's seen in cities across the US. And this tree cover disparity is it's not a causal relationship, it's a complex one, and it's driven by things ranging from, systemic issues of racism, things like redlining and past land use issues, as well as present practices today and land use practices today. So there's a range of complexities behind this, but it does mean, it does complicate plans to green our cities. And it also, even though it's a nationwide trend, we also see it right here in Tacoma. So South Tacoma has lower tree canopy cover than northern parts of Tacoma. It also has warmer temperatures. So this is again from that urban heat island analysis. And you can see the darker red colors are the areas with higher temperatures based on their analysis. So these disparities in tree canopy cover lead to real environmental differences that can and do affect people's lives. So especially as we're seeing these increasing temperatures, we're seeing increased health problems associated with those temperatures in the region. And so this is an area of concern. But the complications arising from these unequal cover in tree canopy and the legacies of redlining and other systemic discriminatory practices that have taken place means that it's not a straightforward problem to address. And there's a real need for collaborative on-the-ground research to understand these patterns and also understand how we can address them in ways that the community realizes the benefits and feels part of the solution, especially in the face of climate change. And so that is really at the heart of our work of the Greening Research in Tacoma project. And as part of this, I wanted to take a pause for my talking so that you hear from some other people in the who are participating in this research. And I'm going to have Lowell show a video that our Greening Research in Tacoma team put together with a firm in Tacoma called Foster's Creative. So I'm going to pause my talking. You can listen to some other voices for a moment and learn about grit.
City has a goal of getting to 30% tree coverage, and right now we're at 20%. And to get to 30%, we would have to plant 1 million trees. The GRIT project is a project happening in the Tacoma Mall area. It's really an effort to understand what the quality of life is in the mall area and hopefully study some things that can help us make it better in the future.
Today, we are going to download some of the temperature data that is being collected on our temperature loggers that are set up on utility poles throughout the South Tacoma Mall neighborhood. So we're monitoring temperature in the neighborhood, and we've set up these loggers to be in locations where there are street trees planted and in areas nearby where there are no street trees planted. We're trying to understand the effect in this neighborhood that trees have on temperature. Also, we're measuring temperature in green spaces in the neighborhood, so more forested areas, to kind of capture the full range of temperature in the neighborhood and how trees and how the amount of trees and the size of trees that are present can affect temperature. So we're trying to understand how trees are affecting temperature, how they're affecting the temperature that people experience, especially on hot days when the temperatures can be really dangerous to people in the neighborhood.
I have a problem with the fact that we allow the developers to take down old trees and then we give away new trees. And I'm not opposed to giving away new trees and encouraging people to planting them. But it seems to me we should be hanging on to the ones we have.
We talk a lot about the health benefits, the ways that trees support reducing temperature and help us adapt to climate change. This project is helping really make that real in a way that we're trying to understand how the neighborhood actually changes, and we just don't have that opportunity away.
We're thinking about, relationships between humans and the natural world and how that might impact human well-being.
As the climate continues to warm and we see more and more impacts, especially in urban areas, more research needs to be done, particularly in this realm of social ecological systems. Like, we know now that you can't just look at ecology and not consider people.
More trees in a neighborhood is correlated with better social cohesion. When we think about the future and the way that the climate is changing, the way that temperatures are fluctuating, it's really important to have a very good physical environment around us that can help us deal with these big changes and big impacts.
trees can provide shade, and it sounds really simple, but on some of those hot days that we get in the summer, that shade is critical to being safe and feeling healthy and able to thrive in a neighborhood. They also do literally clean the air by taking out harmful pollutants from the air. And there've been a lot of studies showing that there are mental health and well-being benefits to even just seeing trees, but actually living with trees and experiencing them.
The big thing that we're trying to work on is tree canopy cover in urban areas. There's a big lack of that, often along historic redlining. And so that presents an equity issue, and you're getting neighborhoods that are sometimes as much as 20 degrees hotter in certain areas, like just a few blocks apart from each other. And so that has a lot of negative health impacts. It has just far-reaching negative impacts on the community.
It's important that we understand how people living in those neighborhoods are actually experiencing those trees. Are they realizing and experiencing the benefits we think they should be getting from these trees? Or is their experience different? What are we missing?
Cities play a really key role in kind of taking initiative and making themselves more sustainable, but in doing so, they can also increase community resilience and just make these places where people want to live, where they like to live, where their needs are met, where they're healthy and happy. And I think there's, more research coming out and people are understanding how all of these things can align, how city planning, how public health, how the environment can all intersect and kind of achieve all of these goals simultaneously.
Trees are something we can all rally behind. It's something we all know is important on some level. We have trees available, and that's why we exist as an organization, to educate people about the urban forest and to connect people to the resources that they might not have or they might not think of getting on their own. So if you want trees, you can work with Tacoma Tree Foundation and give you trees.
Thanks, Lowell, for sharing that. So now you've all been able to hear from some of the folks involved in this work, and hopefully have a better idea of our GRIT project. And now I'm going to share a little bit of some of our research updates. So we're in the process now of the project has been going on for just about a year. And I'm going to share some of our environmental research. So as the project, as the video hopefully came across in the video, we have kind of a couple of different components to our research, including how do trees in the neighborhood affect temperature, but also how does this greening affect people who live there. And I'm not going to be talking about that second question at all. I'm really focusing on this question today. But hopefully we'll hear from the researchers at UW who are really digging into the effects on people at another date, hopefully another Tacoma Tree Foundation lunch and learn perhaps in the future. But I wanted to share some of our research results on this first question. And I do want to note too that this work is ongoing. I'm still analyzing the data. I was really digging into it some more this morning, and I've got lots of exciting work to do. And so part of the motivation for talking with you today is to also hear what you're curious about and how you would like to see these data analyzed in ways that might be interesting and important to your lives. So anyway, let me get into some of the details on our research, how we've done it and what we found so far. And then I'm excited to get to your questions. So across this neighborhood in Tacoma, which hopefully looks familiar to you if you're familiar with the city. So north this way, there's I-5. These blue dots show locations in the neighborhood where we've installed temperature loggers on utility poles, thanks to Tacoma Power. And these are at 57 different locations across the neighborhood. They look like this. They're housed in solar radiation shields, which helps make sure the air temperatures they record are accurate. But inside those radiation shields, there's a small logger that's maybe the size of a quarter approximately. And it's got a little computer that's constantly recording temperature every hour. And we check on these periodically and download the data and then look at it. So we've been also at the same time, we've gathered field tree data within 10 meters of each logger. So noting the size and species of trees within 10 meters. And then we're also integrating this data with other types of land cover, traffic, cloud cover, and data as well to help just understand what affects temperature in the neighborhood and evaluate different ways of measuring greenness and canopy cover, whether it's on the ground or remote sensed data. So far, I'll now jump right into findings from the field. I'm just going to share a few, but then if you have more in the questions that come up, I'm happy to share others if I can, or tell you about planned analyses. So based on these analyses, just as you might expect, this is not really a surprise, but we've measured cooler temperatures when trees are nearby. So when I say trees are nearby, it's usually street trees like this one and within 10 meters of the logger. And here on the right, I'm just showing a bar graph that demonstrates that. And these are two loggers that are very nearby each other. One has no trees within 10 meters and the other one has trees. And so the ones with trees have cooler temperatures. But we have noticed not as cool as the forested park that's nearby. So this is, even though street trees do help, they don't help as much as a larger number of trees in a forested park. So these data are from, I'm just pointing to the particular loggers where these data were summarized from. And so these are along South Tacoma Way. And then the park is South Park here, this logger in the park. So you get a sense of where those are coming from. And then these sun icons here are showing where we recorded the hottest temperatures in July and June. And those temperatures were about 100 degrees Fahrenheit, 36 degrees, I think was the maximum we recorded Fahrenheit, or sorry, Celsius. But as suggested by that bar graph I showed with the forested park compared to the other street tree logger, we see that more tree canopy does more cooling. So it's not just presence or absence of trees, but it's how many trees or how much canopy is there. So we see that the maximum daily temperature we recorded, and this again is in Celsius. I probably should convert these for you to Fahrenheit to make it more intuitive. But the temperatures decline as cover increases. And so this was something, I mean, that's not really a surprise, but the fact we weren't sure what this relationship would look like. And what we've found, it seems that on most days, it's a linear relationship on hot summer days. So I find this to be interesting and important because what it means is every bit of tree canopy cover that we add helps cool the temperatures. And I wasn't sure that that's what we'd find. I wasn't sure if the relationship, instead of being linear, would look more like this, like some kind of threshold where you need to get to a certain number of trees before you'd see an effect. But based on our data so far, it really seems like it's most often this kind of linear relationship. So I find that kind of motivating and interesting because it means every tree we plant, every bit of canopy cover that we add is having an impact on reducing those urban heat island effects. And we are using these data. Also, we've compared these data with remote sense data. So again, this is a map of Tacoma, the neighborhood where we're doing this work. These black dots now are those temperature loggers. And you can see this is kind of what we're working on next, which is building in some other data sets to understand how does traffic affect temperature? How does traffic in combination with finer scale vegetation, so not trees, but more grass and other lower vegetation, does that have an effect on temperature as well? So we're using some of these other data sets to understand those questions. That didn't work the way I wanted it to. Sorry about that. But we're starting to explore these impervious surfaces as well, the percentage of impervious surface and how that affects temperature in addition to vegetation and traffic. And so I'm still working on building those data sets in, but that's something that we're working on. And the other kind of future direction that we're quite excited about and will take place in the future is this gray box is showing the location, the approximate location of the Madison greening green infrastructure installation project that's happening in the neighborhood. And because we have this year of data collection across the neighborhood before that project goes in, we're really in a great position to understand the effects of that project. And that's really one of the goals and unique opportunities of GRIT is not just understanding correlations as they exist on the ground now, but being able to monitor and understand how an intervention like this green infrastructure project that's happening right now affects fine scale temperature that people are experiencing in the neighborhood. So you may have seen the construction that's going on these streets right now in the Madison district. They're currently, I think, doing some sidewalk installation and other work, and later in the fall they'll be planting trees. And we have like future research questions that will be really focused on the human well-being and environmental effects of this specific intervention. And so I'll be really excited to learn if we can actually quantify any changes in temperature in the environment as that installation goes in the ground. And as that goes in the ground, we're also going to be, and I noticed that Olivia is on the call, so she's one of the researchers at University of Washington who's leading this work, but she's been surveying residents about their experiences, and she will continue to lead some of that work before and after the Madison tree planting takes place. So if you've seen one of these postcards already, great. If not, you might see them in the future if you live in the neighborhood, as we'll be looking for participants in future studies as well. So that's my brief kind of snapshot of the research and results so far and our greening research broadly in Tacoma. And thanks so much for listening. And I'm happy to talk more details about the research that I've done. I wanted to kind of hear from you what your questions are before getting too much in the weeds of that. So I think I'll stop my lecture at this point and listen to your questions. I'll keep my slides up in case we want to refer to any again. Does that sound good, Lowell?
Yeah, for sure. I think we have a couple of questions already in the chat, so we might start there or in the Q&A box. And then if anyone wants to answer or ask a question live with audio, I think we can enable that. So we'll start with Rob's pair of questions first. Rob is writing about the impacts of Interstate 5, and as you can tell in this map, that's one of the boundaries of the neighborhood that we're working with. And Interstate 5 has a lot of impacts on the neighborhood, air, noise, and heat pollution, among other things. And so the question Rob's asking is, would the approach of planting trees work to mitigate some of the impacts of I-5 on the neighborhood?
Mm-hmm.
And then if that seemed like scientifically sound, what about having a community land trust kind of model to help execute that vision? So I think that refers to acquiring property in order to plant trees and care for trees and create that buffer. What do you think about that, Ailene?
I think it's a great idea. I think that there is research that has shown that, you know, trees can help to mitigate air pollution and sound pollution. I would be really curious to know, well, I can't answer definitively because I feel like I think there is a lot of kind of nuance to that. So it might depend how many trees, how big they are, and how far and what species they are, sort of how far they are from the source. So I think if that was the goal, I think it probably would work, but we would need to look into some of the details of it to make sure they were planted in the most effective way to address the problem that they're focused on. And I also, I think this is a great question, and I love the idea. I also, we're thinking about pursuing some additional environmental monitoring equipment in this neighborhood that would be monitoring air pollution. And so that would allow us to better understand some of these types of questions, to be able to quantify how do trees affect air pollution in this particular neighborhood, you know, given all the other things that are going on. So if something like that were to happen, it would be a great chance for us to kind of monitor and document and learn from a planting like that.
Yeah, and I think short of like acquiring a lot of property, we could also encourage our public agencies that own property to steward the land differently and add tree canopy.
Totally.
The interstate corridor is owned by the state of Washington, operated by the Department of Transportation. They're planting some trees in Tacoma right now, but only on the new construction area. And so the South Tacoma area is not getting that treatment, at least as far as I know.
Yeah.
Rob's next question.
I just wanted to also mention that I did notice several of our other GRIT team members are on the call, so are on the lunch and learn. So I would just encourage them, if they have things to add, to either put them in the chat or share their thoughts as well.
The next question is one that we've talked about a lot in our group planning meetings about this, and it's about the proposed mega warehouse at the Bridge Industrial site. And long story short, for those that aren't briefed on this, it's a proposal to convert what's currently open space and kind of a degraded wetland into large warehouse complex. And so the question here is, what would something like that do to air temperatures in the neighborhood?
Mm-hmm. Yeah, that's another really good question that we should be able to answer once with these data. I can't answer it right now because I need a few more details again to be able to answer it. But I mean, broadly, you could say, more traffic and fewer trees, and less vegetation broadly. It's not just trees, will probably lead to increased temperatures, but I couldn't say how much for sure without knowing kind of how much trees and green space would be lost and the level of kind of traffic that would be added. But with the modeling that we're working on now, we would be able to answer a question like that if we had estimates of, what's being lost and then what's being added as far as traffic and impervious surface.
Great.
So you could follow up with me and we could work on answering that question, which would be a kind of a simple math problem that would be fun to tackle to understand that.
Right. It'd be converting X acres of vegetation into X acres of impermeable surface that traps heat, right?
Exactly. Yeah.
So Jim is asking a question a little bit more. I'm going to summarize this, Jim, just to say, are we providing or looking at tree height, DBH, or like the width of a tree's stem or trunk, and then percentage of canopy closure to understand these relationships? So are we looking into tree specifics alongside this other data that you're talking about?
Yeah, so we have data on, we don't have height data right now, although we could get that. We have DBH, we have percent canopy cover, We also have total basal area. This is all like within 10 meters. And so far I've done some comparisons of what kind of types of descriptions of the tree data best explain variation in temperature. And it's so far it does seem to be the field measured canopy cover that does the best job. So canopy more important than just the basal area or the diameter of the trees. I didn't look at height, so I don't know that, but it would be interesting to do that. And certainly more than the like just presence absence of trees. And so far it does seem like also the field measured data is a better predictor of temperature than the remote sensed canopy cover data, which maybe isn't surprising, but they are related, and the remote sensed data does a pretty good job. So that's like what we're working on now, is expanding, using the remote sense data to kind of expand our model across areas where we didn't measure the trees or the air temperature, but using that as a proxy to predict where temperature would be highest. And sort of that relationship is what we would use to extrapolate or to estimate what we think the effect might be in using changes, for example, like the development that's being proposed in the neighborhood.
Yeah, and Jim's follow-up question, I think we're going to have to table for a later conversation about Seattle's new street tree or tree ordinance that was passed. Short answer is Tacoma doesn't really have tree preservation ordinance in the same way that Seattle and Lakewood have. So if you come to the State of the Urban Forest event on May 25th, you'll hear about what changes the city is making and what progress is being made on tree policy. Does anyone else have a question? You can raise your hand. If so, I can let you come off mute if you want to.
And I saw Mike said that we do have tree height information available. So that would be really interesting and useful. I'll reach out to you, Mike, about getting that data. The other thing that I'm curious, so we do find that just while I'm waiting for questions, I'll just talk some more. Well, we haven't looked at tree height or species differences specifically, but I would be curious at least to look at evergreen versus conifer versus deciduous trees. But I would predict, because we see that percent canopy is the best predictor, I would expect that species that have big canopies do a better job of mitigating urban heat in the neighborhood based on our data, and also based on other studies that have been done. So species that tend to have larger crowns and greater canopy cover do a better job at mitigating this urban heat island effects and temperature increases.
Great. All right, Jim is asking, what could you use for help in your research from the public and volunteers? And that's a great question, because I was also going to ask you to talk a little bit about this temperature jamboree that we're planning for next month. So maybe you could share about that.
Yeah, I will. That's great. Yeah, there are lots of things you can do to help. And so certainly, like, getting on the Tacoma Tree Foundation's listservs and helping them with their work is one of the biggest things you can do to help. If you're particularly interested in the research side of things, we have an event coming up on May 13th that we're calling a temperature jamboree, which is to help us gather some additional temperature data. So as I showed, we have temperature loggers that are continuously or every hour collecting data on, just going to pull it up, on these utility poles. But we're also wanting to understand sort of how surface temperature is measured in the field compare to that. So we've been doing that so far we did a preliminary event or a pilot shot at this last summer on a hot day, went out and had volunteers take temperature loggers and leave them on the surface adjacent, the ground surface adjacent to these air temperature loggers, so that we could have a comparison. So that's one thing you can do to help us better understand kind of the range of temperature effects that trees have, both on surface or lower height air temperature, as well as the heights that we're measuring along utility poles. And then I guess just stay tuned, because we might be expanding to do some air quality monitoring as part of this research as well. And so we would, if we do that work, we'd be looking for volunteers to install some air quality monitors that we would provide, and then the data would be shared to a network of publicly available air quality data monitors that we could use. So that's something we're kind of looking into, but we might look for that in the future as another way to engage, besides just volunteering with TTF and participating in events like our temperature jamboree.
Yeah, and on the topic of air quality, that's something that came up in our meetings with the community advisory group that we have. So if you are someone who lives in the Tacoma Mall neighborhood or works in the neighborhood, you can actually keep in touch with us. We have meetings roughly every quarter of the year, and we ask for feedback from the community about how to make this research applicable to your daily life. And that's where we have been talking about this idea of monitoring air quality. And part of the reason that came up was the warehouse proposal that we were talking about earlier, because residents are really concerned about what's going to happen to the quality of the air if and when that warehouse complex is built. Are there other questions out there in the audience? Feel free to raise your hand. If you do that, I can take you off mute. If not, we can end early.
Jim has another question. I see. What could, oh no, you already have that. Jim's question.
Covered that one.
Yep.
Mike's putting some great content into the chat as well, into the Q&A about the air quality campaign going on in Tacoma.
Yeah, and I think that the relationships between urban trees and air quality are less well studied than temperature effects. So that would be a really exciting and newer area for us to get into in this project. So I hope that we're able to do that work in the future.
Very good. Question from Caitlin. What is the actual difference in temperature between no trees and trees? It seems to be very small on the chart and the data you're looking at.
Yeah. So we found, and I meant to give this figure, but on average across the whole year, it was about 0.5 degree Fahrenheit. And if you just looked at the average of loggers with trees, trees within 10 meters and without trees, but that's like masking a lot of variation. So there's one thing that I did find is big variation from one day to the next in here. I'm going to go back forward. This relationship. So this plot is on the maximum measured temperature on one day, the hottest day that we recorded in June in 2022. And so you can see on here, and this is in Celsius, so it's going to be a bigger difference in Fahrenheit, but with highest tree cover, the maximum temperature was about 32.5. It goes up to here, so about 1 degree on this day, although there's a wide range around that. And this relationship was not it varies from one day to the next. Some days this line was steeper, other days it was more gradual, which I thought is pretty interesting. So even though we can say we have, this effect of about on average a half a degree Fahrenheit, there's a lot of nuance to that, and that's at a fine scale. So that's just within 10 meters of that tree. And so what this is not getting at is, but I hope to get at this bigger question with additional like remote sense analyses. If we combine, like if we look at the aggregate effect of trees in across broader areas, what effect do we see? So I did the one thing that makes me think we may see a bigger effect if we look across a broader area is just that as you add more trees, you do see a bigger effect. So it'll be interesting to see once we start to put together more fully the remote sense data. If we look across an aggregated area where there's more canopy cover versus less canopy cover, what do we see? How much are trees contributing to cooling those urban heat islands? That was a long, complicated answer. I don't know if I got at if I gave you the clear, crisp answer you were hoping for, Caitlin. I guess one thing I could add too is when we looked at the surface temperature data from our temperature monitoring event last year, you see a much bigger effect of trees on surface temperature than you do on these air temperature measurements. And part of that is just the effect of shade of cooling on the pavement. And so we saw more like 15-degree difference of when you include sun versus shade effects of trees on surface temperature. So the effects were much bigger on surface temperature than air temperature.
Okay, we have a few more questions popping in. Are there ever meetings where we can chat in person? Jill, thanks for the question. I would say there's lots of chances to meet us at Tacoma Tree Foundation events on our calendar. You can see where we do tree walks, educational events, and we also table at community events from time to time. So if you drop by the Sustainability Expo this Saturday, for example, you can ask us anything. And to talk with other partners on the GRIT project, the best opportunity is really to come on May 13th to hear more about it and help us collect some temperature samples from around the neighborhood.
Yeah, also, I'll just say that I go down regularly to monitor our temperature loggers. So feel free to email me. And when I'm down in the neighborhood, I would love to have you join me on a walk through the streets of Tacoma Mall area, checking temperature loggers. And I'd love to chat with you. So feel free to email me if that's of interest, and you can join me on some of my field work.
Great. Well, I think that's a good place to leave it for today. I'm going to do one last screen share here and just share our final slide. And that's just to say thanks for tuning in and thanks for being part of our Tree Foundation community. I want to thank also Tacoma Creates for supporting our webinar series, and also to Puget Sound Partnership for the grant that is funding all this exciting research happening in the mall neighborhood. So I think that's all we have for today. These are the different ways you can contact us, follow us online, send us an email, and definitely check out earthdaysouthsound.org to find out some ways to get involved this weekend and this month.
Thanks all, and thank you all for coming. I really enjoyed connecting with you, even if only virtually and only for an hour. But yeah, do stay in touch.
Thank you so much, Ailene. Have a great day, everyone.
Thanks, Lowell.
Thank you.